Alright, so starting off here, got a proof to start off with. It's given that R is parallel to S and S is parallel to T, we want to prove that R and T are parallel. So it's giving us that R and S, these two top lines are parallel. Then it tells us that S and T, the bottom two, are parallel. So we want to prove that the top one and the bottom one are parallel then. Alright, so starting off with the given, part of the given. We don't have to use it all at this point. So R is parallel to S. That's given. So we're looking at the two top lines here. And so if these two top lines are parallel, then we've got certain relationships that we could recognize between the angles. Because if the lines are parallel, then we know what about angle 1 and angle 2. They're going to be the same because those are alternate interior angles. So if the two lines are parallel that are cut by the transversal, then the alternate interior angles are congruent, right? Everybody remember that? So we can put that down. Angle 1 is congruent to angle 2 by the alternate interior angles theorem. So we got a relationship between angle 1 and angle 2. The next thing we're going to do is we're going to bring in the other part of the given, that S is parallel to T. And so if S and T, these two bottom lines, are parallel, then we have a relationship between angle 3 and we actually have a relationship with both of these angles, right? As 3 and 4 are corresponding angles, or 3 and 2 are alternate exterior angles because they're outside of these two lines. And it also always confuses people because this 2 is in between, is below angle R and below side R and above line S. So it looks like it's interior, but when we just focus on these two bottom lines, 2 is in the exterior of S and T. So we've already established a relationship with 1 and 2. So I'm going to use the relationship I can have with 2 and 3 here instead of 3 and 4, because that'll connect these two together. So 2 and 3 are alternate exterior angles, and since S and T are parallel, that means that the alternate exterior angles have to be congruent by the alternate exterior angles theorem. So now if we look at what we've got, besides the lines being parallel, we've got that angle 1 and angle 2 are congruent, and angle 2 and angle 3 are congruent. So if 1's congruent to 2 and 2's congruent to 3, then 1 and 3 would have to be congruent to each other by the transitive property of congruence. Now if we focus on the fact that we've got angle 1 and angle 3 congruent to each other, when we look at line R and T, then 1 and 3 are what kind of angles? What's their relationship? They're corresponding angles. They're in the same spot in relation to the intersection. And so since they are corresponding and they're congruent, then we know that line T and line R have to be congruent, or have to be parallel to each other, because the corresponding angles are congruent based on the corresponding angles converse postulate. So now we can see that all three lines are congruent to each other. Right? R is congruent to S is congruent to T, and now we just proved that R and T are parallel to each other. And what we just proved was this theorem 3.11. It doesn't have an official name to it, but a lot of times it's referred to as the transitivity of parallel lines, because it's kind of like the transitive property, right? If 1 was congruent to 2, 2 is congruent to 3, then we say 1 and 3 are congruent. Well, if P is parallel to Q and Q is parallel to R, then P and R have to be parallel to each other. So it's kind of like the transitive property. Not officially the transitive property of parallel lines, but it's kind of looked at as the transitivity of parallel lines. So if two lines are parallel to the same line, they're parallel to each other. And theorem 312, in a plane, if two lines are perpendicular to the same line, then they are parallel to each other. Right? So if two lines are parallel to the same, or perpendicular to the same line, then they've got to be parallel to each other in order for them to both be perpendicular to the same line. All right. So now this example, looking at the flag of the United States that has 13 alternating red and white stripes. So there's 13 stripes on an American flag. Each stripe is parallel to the stripe immediately above it. So the top stripe is parallel to the second stripe. The second stripe is parallel to the third stripe. Third stripe is parallel to the fourth stripe, so forth and so on. And since that's true, we want to explain why the top stripe is parallel to the bottom stripe, which sounds fairly easy, and it is. It's a lot of steps to get from the top stripe to the bottom stripe because there's 13 stripes, right? So, but I'm just gonna unveil it all right here. So if you take the label, the top stripe as S1, it's in stripe 1, the next stripe as S2, and continue, so that the last stripe would be S13. So it's just giving us a way to identify them all without having to say stripe 1, then the second stripe, then the third stripe, then the fourth stripe. So given that S2 is parallel to S1 because each stripe is parallel to the one immediately above it, so 2 is parallel to 1, and stripe 3 is parallel to stripe 2, we can say that stripe 3 and stripe 1 are parallel. Right? That's 1 was parallel to 2, 2 is parallel to 3, then 1 and 3 are parallel. Right? And so by the transitivity of parallel lines, and that's theorem we just went over, theorem 311. And then since stripe 3 is parallel to stripe 1, and stripe 4 is parallel to stripe 3, then we can say also by the transitivity of parallel lines that stripe 4 would be parallel to stripe 1. And then to keep from having to go through every step of that process, we could then say, since stripe 5 is parallel to stripe 4, then stripe 4 is parallel, or stripe 5 is parallel to stripe 1, so forth and so on. But so continuing this reasoning, eventually we would get down to where stripe 13 would be parallel to stripe 1. It would just take us another 9 steps to get there. And so since stripe 13 would be parallel to stripe 1, the top stripe is parallel to the bottom stripe. Does that make sense? Right. We're comparing each one to the one above it, and then relating them all back to the first one. So, questions there? People still copying it? Those of you that wanted to copy it. All right. So then these last two things here, we're just determining how we could show that K and J would be parallel to each other, or what piece of information we can use to prove that they are parallel. So when I look at the first one there, we got two angles listed as 112 degrees. So what rule or what reason could we use to say that K and J would be parallel? How are those two related based on their location? They're corresponding angles. And they are corresponding angles that are congruent, right? And so if the two corresponding angles are congruent, then we know the lines are parallel by the corresponding angles converse postulate. Corresponding angles are congruent. The corresponding angles converse postulate tells us that the lines have to be parallel if the corresponding angles are congruent. All right, so then the next one down there, got two angles that are both 99 degrees. And what's the relationship between those two angles? They're alternate exterior angles, so what would tell us that if the alternate exterior angles are congruent, that the lines are parallel? Basically, if we can recognize what the relationship is between the angles, then that's basically what we're using, right? They're alternate exterior angles, and it's the alternate exterior angles converse theorem. All right, so that's all there is to the notes for this section. So